everyone. This video lecture is on what we learn in node analysis. We all know or we all completed node analysis unit. So this is just review that what we learn in node analysis. So in node analysis, first step is we learn what is node, how to find node, what is node analysis, for which application we can use node analysis. Then step to solve node analysis problem statement. Then we see how to write simultaneous equation using format approach. So this is our problem statement for node analysis. Determine node voltages in given circuit, also find current. So in my problem statement, two current sources are there. One is a 4 ampere, second one is a 2 ampere, and 3 resistor R1, R2, R3, 2 ohm, 12 ohm, 6 ohm. So first step is, before solving node analysis, first we have to find nodes. So if you observe the circuit, that 4 ampere current source is connected to R1 and R2 at one point, and 2 ampere, 6 ohm and 12 ohm is connected to one point. So this is my first node V1 and my reference node ground, and my third node is V2. So if you observe this circuit, there are three nodes V1, V2 and V3. So number of nodes in circuit are 3. Node equation are n minus 1 is equal to 3 minus 1 is 2 node equations are going to be there for this problem statement. Before solving this problem, first we just look out what is node analysis. So node analysis is a method that provides the node voltages of a network, that is the voltage from various node junction points of the network to ground. To solving node analysis, we are using basic Kirchhoff's current law. The application of node analysis in various points where we want to find the node voltages or the current from node voltages, we can use node analysis. So these are the steps to solve node analysis problem. First, choose a reference node. Then second, assign a subscripted voltage level to n-1 remaining nodes of a network. That's why we choose first V1, then total number of nodes are 3. 3 minus 1 is a 2. That's why I given the labels V1 and V2, and remaining node is my reference node or ground node. Number of node equations is n minus 1. In our problem statement, it is 3 minus 1, so it is 2. Now, there are two approaches to solve node analysis. First one is a classic approach, or which is normally we use, and second one is a format approach. In traditional way, we are writing the current Kirchhoff's law equation and then we simplify it. But if you know the format approach, you directly note down equation. So for format approach, first column of each equation is summation of conductance. Conductance means 1 divided by impedance to node V1 into node voltage into the mutual terms of subtracted from the first column. The mutual term is a component which is connected between the two nodes, and the mutual term is product of mutual conductance and no other node voltage tied to that conductance. The column of right of equality sign is the summation of current sources tied to the node of interest. A current source is assigned a positive sign if it supplies current to a node and negative sign if it draws current from the node. And last one, solve the resulting simultaneous equation for the desired voltage. So we know the steps we know the number of nodes in my problem statement. So this is my first node V1, this is my second node V2, and my third node ground. So first, in short, the formula summation of conductance to node V1 into node voltage, because we are writing first equation at node V1, minus mutual term into node voltage is equal to algebraic summation of current source. So for first node, my equation becomes, for this node two resistors are connected, so that's why it's 1 divided by 2 plus 1 divided by 12, because 2 and 12 ohm resistor is connected to V1, minus mutual term 1 divided by 12 V2 is equal to 4. Now 4 current is incoming to my node, that's why it is a plus sign. This is a node equation at node V1. Now for node V2, R2 and R3 is connected and 2 ampere current is going away from my node. So that's why my mutual term is a minus 1 divided by 12 V1 plus bracket 1 divided by 6 plus 1 divided by 12 V2 is equal to minus 2, because current is drawn away from my node. Now the first simplified method, write according to V1 and Vt terms, because to writing a matrix it is very simplified manner, that writing a equation in a matrix form, it's become very easy if you write your equation in this manner. So if you simplify this equation, first equation becomes 7V1 minus V2 is equal to 48. Second equation, minus 1V1 plus 3V2 is equal to minus 24. So my matrix is 7 minus 1 minus 1 3 V1 V2 is equal to 48 minus 24. It is my conductance, then voltage, and then my current matrix. So it is nothing but simple my Ohm's law, that V divided by Z is equal to I. For V1, the formula is delta V1 divided by delta or determinant. So it is 7 minus 1 minus 1 3 is my determinant. For delta V1, replace first column by current matrix. So it is 48 minus 24 minus 1 minus 1 3. To solve this determinant, 48 into 3 minus 1 minus 24, cross multiplication minus second term, 7 into 3 minus 1 minus 1, it is equal to 120 divided by 20 is equal to 6 volt. For V2, same steps perform, answer is minus 6 volt. By using this, we can also find current. So for I1, resistor R1 is connected between V1 and V reference. So 6 minus 0 divided by 2 is equal to 3 ampere. Current flowing from V1 to ground. I3, V2 is equal V2 minus V reference divided by R3 is equal to minus 6 minus 0 divided by 6 is 1 ampere. V reference is your ground voltage and its potential is 0. Now you think here answer should be minus 1, but 1 ampere current flowing from ground to V1, that's why it is 1. If you write minus 1, then also it is okay. Then you don't have to write this current flowing from ground to V2. For R2 is connected between V1 and V2. V1 we calculated 6, V2 we calculated minus 6. So that's why I2 becomes 1 ampere. Now it's time to test yourself. This is a simple circuit. Try to find the node voltages for this circuit. This is your homework. I hope you like this video lecture. Thank you.
So, I am using multisim to simulate our problem statement. The problem statement is having 4 ampere current source, 2 ohm resistor, 12 ohm, 6 ohm, 2 ampere. Now I connected 2 DMF at node 1, node 2, and I am going to cross check my answer, which I previously solved, that V1 voltage is a 6 and V2, my second node voltage, is a -6. If you don't know how to install or how to use multisim, then please refer my video lecture on series resonance multisim simulation. In that lecture, I explain how to install multisim, how to use it. So, if you're not comfortable with multisim, you first install it, use practice, and by using multisim, you can cross-check your answer for any circuit. If you want, you can use also, there are so many software which you can use for this simulation. PSpice, Tina, there are various softwares are available. It's your choice, but it's give you a in depth that actually what is node voltage and what we are calculating. So the first terminal I calculated or I connected to first V1. So V1, I already explained you that V1 is not that point. It is every point that my first, second and third component is connected. This is my ground and this is my second DMM. So here it is showing me 6 volt and here it is showing me -6 volt. So see, our results are correct. So by using this simple softwares, I hope the concept of what is node voltage analysis is clear. Still, if you are having any doubt, please ask me or give your valuable feedback to improve this lecture. Thank you.